So like I said, it's going to be like yesterday. We're going to have the proportions, we're going to have the cross products, but we're going to add the geometry flair to it. We have to talk about corresponding parts again. So a few things we do need to fill in for the vocabulary. So we have similar polygons, not congruent. We've done a lot of congruent stuff. Similar polygons. They have the same shape but different size. So the first blank you need to fill in on your notes, size. So these are going to be similar shapes but different sizes. They are not the same sizes. No isometry. Can't help myself with the vocab anymore. So they're similar. If you have corresponding angles, have to be congruent. So we're going to see that. We're going to see congruent angles. We know how to match that up. We've seen that. And here is the difference. The sides are not congruent. They are proportional. So you're going to have those fractions today. We're going to be comparing the sides of these similar polygons. A lot of triangles today. Now, the ratio, remember, ratio, fancy name for fraction. The ratio of the corresponding sides gets a very lovely name. You don't have to write this, just I would kind of maybe highlight it. We call it the scale factor. And of course, I need a bigger screen. If polygons are similar, their perimeters are also proportional. And we've reviewed perimeter in here where you have to add up all the sides, of course. We have ready to writing. Okay, let's look at these pictures because this is kind of what we're going to be doing in here today. So you can see you have these similar polygons. Of course, mine are red and blue. They're the same shape but different sizes. Clearly the red one's bigger than the blue one, okay? So the angles, of course, you know how to do corresponding angles. We've already done that. A corresponds to E. You know this. B corresponds to that guy. C, G, D, H. You know how to do that. That's nothing new. Here's the different part. The sides. The sides are not congruent. They are proportional. So you have the fractions. So in the past, we would match up our two letters like A, B, and E, F. They're not congruent. They are proportional. You have the fraction of the sides. They're not congruent. The other thing, and this is super, super tiny, and I kind of like made a mess here writing on all of this. Notice your symbol in between those, this guy. You don't have a congruency symbol. It is just a squiggle. There's a big one of it. That means they're similar. That means the angles are congruent, but the sides are proportional. So you're going to see that little similarity symbol today. So first thing we're going to do is just practice answering these lovely questions. Write a similarity statement for the triangles. Okay, I'm going to start with the triangle up top, the small one. So you know me, I always kind of work in an order, single, double, triple. So I'm going to start with the single congruent mark, go to the double, then the triple. So I'm going to call it A, B, C. Now remember, not congruent today, we are similar. Similar. They obviously similar sizes, but they're not congruent. So again, I'm just going to match it up, single, double, triple. I'm going to call the second triangle D, E, F. So there is my similarity statement. Now, let's do the scale factor. This is easy, just read closely. Triangle ABC. So you have to start with that one. So we're going to, of course, pair up the sides. Gentlemen, let's make sure we're focused on math here today. So start with the small triangle. It doesn't matter if you pick the 8, the 10, or the 14. Pick a side, okay? I don't know, I'm going to do 10. Now, on the bigger triangle, what side does 10 correspond to? 15. So there's my scale factor. Now, of course, I would reduce that. What's 10 over 15 reduced down to? 2/3. And you don't have to write this, but I just want to prove to you it works for whatever side you pick. Let's say I did the 14. 14 corresponds to what? And guess what you get when you reduce that? 2/3, okay? Same thing if you did 8 to 12. You get 2/3. So it doesn't matter which set of sides you pick. They will always be the same. You'll always get the 2/3, okay? Just for the record. What is the scale factor of triangle DEF to ABC? Well, okay, I don't think we have to do too much work, so they want it reversed. So instead of 2 over 3, it's going to be 3 over 2. Okay, well, that's exciting. Great, I don't have to do anything, I like it. So we just have to read closely which triangle to start with. That's not a big deal. Okay, what is the ratio of the perimeter of triangle DEF, and I'm off the screen there, to triangle ABC. Okay, we gotta go back to the pictures. We need a little work here. Perimeter, how do you find perimeter or anything? Add up all the sides. So let's do the perimeter of the top triangle. What's 8 plus 10 plus 14? Yes, you got it? Let's do this guy. What's 12 plus 15 plus 21? Got it. So the question is, I gotta scroll it back down, we gotta read closely. Am I going to do 32 over 48 or 48 over 32? So perimeter DEF to ABC. So you're starting with the bigger triangle, so 48 over 32. And of course, reduce it. What does that reduce down to? Use your calculator if you got to.
1/3, or 3/2.
3 over 2, 3 halves. 16 goes into both of those. So again, nothing too crazy whatsoever. Just make sure that you read closely so you know what triangle to start with. Any questions on that? All right, let's do something besides a triangle. Let's mix it up, flip the page, and do a quadrilateral. So in the diagram, quadrilateral ABCD is similar. QRST. What is the scale factor? Read closely. We're starting with this guy. I'm starting with the small guy. So what's the scale factor of that one to ABCD? Now remember, it doesn't matter what side you pick here. Of course, we just gotta, pick one. I'm gonna do 6, I don't know. Now, 6 corresponds to what side on the other one? 12. So I'm gonna have 6 over 12. That's easy enough, reduce it. Got it. Okay, so that's the first thing they wanted. Then it asks you to find the value of x. Oh, okay, we can do that. So I'm going to find where x is. So x, of course, corresponds to what side? Okay, so here's what I'm going to do. Because we're going to make a proportion like you did yesterday. And I'm going to steal this same scale factor up here we just found. I'm going to use it. So I'm going to use the 1/2 as one of them, one of my fractions. Now, here's the question you have to be super conscientious about. Bless you. So we did the 1 over 2, or the 6 over 12 is what I started with. 6. I started with the 6. So am I going to do this one as x over 4 or 4 over x?
4 over x.
There we go. So just make sure you match up which triangle or quadrilateral you start with. Little cross products, we got this. 1 times x, 2 times 4, and we're done. I like a nice easy problem. So again, super easy, just if you start with the small ones, keep with the small one, Common sense, right? All right, list all the congruent angles and write a proportion that relations the corresponding sides. Okay. So first off, kind of zero in on this. So they don't have anything marked on the picture yet for me, so I'm gonna have to figure this out and mark it, which is fine, I can do it. So again, I'm gonna pair them up. First angle is J, I'm gonna do that guy in purple, I'm gonna put a single on it. That corresponds, of course, to P. See, you would have maybe thought N, but you gotta look at that statement close. Okay, all right, you're not gonna fool me. I'm gonna do K in blue, I'm gonna put a double on K. K corresponds to which one in the second triangle? M. So 2 on M. Obviously, we got the last ones right, L and N. So I'm gonna go ahead and list the angles over here. We've got them marked, let's just list them. I'm gonna do the single ones first. J is congruent to P. I'm gonna do the doubles, K and M, the blue ones. And then, of course, I'm going to do the triples. Angle L congruent to F. Okay. Now here comes, if you ask me, the tricky part, the sides. Now remember, the sides are proportional. I'm not going to put congruent marks on them, but I'm going to kind of color code them to make our life easy. I know it's hard to see in yellow, but I'm going to do the first one in yellow. So I'm going to pick a side here on the first one. I'm going to use the first 2 letters, JK. So I'm just going to kind of highlight it there. Now, what side does JK correspond to on the second triangle? PM, those first 2 letters. And notice, I know the yellow's hard to see, apologize about that. Notice I didn't put congruency marks on the sides. They're not congruent. Clearly the triangles are different sizes. Okay, my other sides. So let's do like the outside 2 letters. So JL. What does JL correspond to in the bigger triangle? PM, your outside letters, P and N. I'm just going to highlight that in black. And I'm pretty sure we got the last sides figured out, right? The ones that I don't have anything color coded on. So I'm going to do KL. I'm running out of room here. And then obviously our other one, we'd have NM. So again, notice I didn't put congruent marks on them because they're different sizes. In the past, we had congruent figures. Any questions on that stuff? All right, easy. We just got the same thing. We got to match up the stuff pretty much. It's a matching game. In the figure below, so they're similar, scale factor 2 to 3. Okay, so I'm going to start, you know, I like the fraction versus the dots, 2 to 3. Now, here's the question, what we got to be smart about. Am I going to do my next fraction, is 42 over x or x over 42? Yes, it does matter. Because your scale factor goes small to big. So you have to start with the smaller figure. So 42 over x is the width. So small to big. Okay, we can solve that. Do your cross products. So we're going to have 2 times x. What's 3 times 42? You probably need your calculator for that. 126. You got your answer, x is. Got it. So you just have to watch your fraction setup. You started 2 to 3, so this one started small to the big. Okay, this one's 6 to 5. Okay. So 6 to 5. So we're going big to small, big to small. So is it x over 28 or 28 over x? Good. Big triangle to the small one. So that's the only tricky part of today is you have to watch your fraction setup. Now it's super easy. Okay, do your cross products, of course. 5 times x. Need a calculator for that. What's 6 times 28?
168.
And you're going to get a not nice answer. We saw some decimal answers. You're going to get some decimals today. So again, easy. Just make sure you're starting with the correct figure from your scale factor. All right, triangle ABC, similar to DEF. Find the value of x. Okay, so I'm going to start with the side with x on it. Now, that of course is my side AB. So what side does that correspond to in triangle DEF? DE. So I'm like, okay, DE, got it right there. So my first fraction, I'm going to do x over 25. Now again, I'm back here starting with this triangle, clearly ABC. So now I'm going to do the other set of sides, 28. And that corresponds to what side on the little triangle? 20. This is pretty much what we're doing the rest of the week, setting up these proportions and solving them. All right, cross products, here we go. X times 20, easy. 25 times 28. We're going to get a big number there. Final answer, x is 35. Love this stuff. Anybody miss proofs yet? Nobody? Okay. So again, same spiel, just be careful matching up your sides. That easy. It doesn't get any trickier than this. All right, triangle DEF, the little guy, similar to that one. Find the values of x and y. Okay, all right. Well, I'm just going to do them in order, of course. I'm going to do x first. So I see x is over here on HG. So I'm going to start with that guy. HG corresponds to what side on the other triangle? DF. All right, so DF, here we are, 12. So I'm going to do 12 over x. Now, I don't want to use the side with y because that's going to be a separate fraction. I'm going to get to that. So I'm looking at the 15 side. So JH, the first 2 letters. Okay, all right. So that's going to correspond to DE. So my second fraction, careful here, am I going to do it 15 over 9 or 9 over 15? 9 over 15, because I started on the small triangle on the first fraction, so I start on the small triangle again. Now, super easy, let's just solve that, of course, right? 9x, 12 times 15.
180.
And this one comes out nice, x is, okay. Now, here's what I'm going to do. I'm going to work smart here, right? So here's the thing. The 9 and the 15, of course, still correspond. I'm just going to keep that right as it is. I'm just going to rewrite it what ups. Now I'm going to look at, of course, y. Well, what side does y correspond to in the first triangle? What's the only one left? So, is my fraction going to be 14 over y or y over 14? Because remember, I did 9 over 15, so I started with the small here. 14 over y, so the small triangle to the big. Now just do your cross products, of course, okay? So let's multiply 9 times y, 14 times 15, you need your calculator for that, that's 210. This does not come out to a nice answer, round to whatever. Got it. These are quick. So again, you just have to be careful about keeping everything arranged and set up corresponding. Any questions on that guy? All right, home stretch, we're on the home stretch. Okay, again, read your similarity statement. Triangle TLY is similar to triangle CHK. So the left is to the right, okay? So here we go. So I'm gonna start with a nice number. That seems like a nice place to start, meaning I'm gonna start with 25. So I see that that is TL. TL corresponds to what side on the other triangle? CH. CH right there, 10. So my first fraction, I'm going to do 25 over 10. Okay, then I'm just going to, of course, go back to my next one here. I got my LY, which of course, the last two letters. And really, it's the only other side marked over here, but let's just make sure, HK, of course. So there's my setup. You know the drill. Cross products. Now, pro tip here, if you wanted to, like 25 over 10 to me, 25, 10, kind of big numbers. Can you reduce 25 over 10?
Yeah.
Yeah, so if you wanted to, 5 goes into there, 5 goes into 10 twice, you could reduce that down. Do you have to? No. You'll get the same exact answers, whichever one of those proportions you solve. It's just whether you want to do a little bigger numbers or not. Whatever, doesn't matter. I'm going to do the smaller numbers because I'd rather do that. Because I can distribute 2 through that in my head. 2 times 4x, 2 times negative 1. Got it. I can take 5 through this in my head. 5 times x, 5 times 5. And I'm just going to keep on going. I'm going to subtract 5x over. You guys probably have an answer. So I'm going to have 3x. I'm going to add the 2. What's your final answer for x? 9. Okay. Now, final answer. Find LY. Okay, all right. So LY is this guy. We can find LY pretty easy. You know x is 9. Let's just mental math it. What's 4 times 9 minus 1? 35. I'm going to add that to my answer too. Got it. So you would have gotten 9 if you solved this red and blue fraction at the top. I just decided to work with smaller numbers so I didn't have to bust out my calculator, okay? Any questions on that guy? All right, home stretch, here we go. Triangle JKL, okay, all right, so the big one here, big one, similar to the little guy. Find the values of x and y. Okay, all right. Well, let's pick a side here on JKL, and it doesn't matter what side we pick. I'm going to do the 40. I'm going to start with that. So I see that's JK. So 40 is going to correspond to what side on the little triangle? Got it. Which I'm going to find right there. So 16. Yes, you could reduce that if you would like. Okay. So find the values of x and y. I'm going to do x first. So on the big triangle, that's why I started to see x is on KL. KL. So KL corresponds to which side? ML. So the 14. Now again, you could reduce the 40 over 16. You can solve it as it is. It doesn't matter. You decide. I'm guessing you're just solving as I hear the calculator keys going. Forgot the x. You already have an answer?
Yeah.
You guys are fast. Okay, what do you have for your answer? I'm sorry.
35.
35, agree. You don't need me to do the work apparently for that. Okay, let's do the y now. Now again, make your life easy. You already figured out the 40 over 16, just keep it. But of course we want to switch to the y now. So here's my y side, ln. What's the only other side on the first triangle it's going to match up to? So, careful, second fraction. Is it y over 45 or 45 over y? Good, you gotta start with the big one. I'm not even gonna waste my time trying to do the work because you guys probably already have the answer for it. 18, yeah. I'm okay writing all of that. Alright, any questions on that guy? I love this stuff, I could do it all day. Okay, one last fun one. The triangles look a little different because why not? We're gonna start seeing more pictures similar to this in some upcoming sections. But it's the same thing, same thing. Okay, triangle, BNV, so this little guy, because there's a lot of triangles on this picture, is similar, let me do the other one in red, BRG, the big one. Okay, all right, got it. So BR, it tells us, of course, is 4x plus 7. BG is 18. Find the value of x. Okay, so one thing I'm going to do here is look at this BG is 18, because I think I'm going to need it. If this whole thing BG is 18 and you know this side is 8, what's this missing piece? 10. And you know I can't help myself. What postulate is that called when you add two little segments together to get the big one? Segment addition postulate. It's all coming back to us. Okay, so here we go. Let's do this thing. So BR is 4x plus 7. It tells you that too. So I'm looking at what that corresponds to, BN. So I'm going to kind of set those up first. So I'm looking at the picture. BN 12, got it. BR 4x plus 7. Okay, so back to it, of course. So then I'm looking at my BNV triangle here, my little blue guy, my triangles here, all the crazy triangles. So of course you've got the 12 on it. So I'm guessing, you know, we gotta do something with the 8 side, the BV side, the outside two ones. Okay, side BV corresponds to what side? BG. And what is BG? 18. Now, of course, you could reduce 8 over 18 if you wanted, or just roll with it, which I'm guessing most of you are just roll. I would reduce it, because I don't want to get my calculator out. So, of course, 2 goes into there, 2 goes into there, and then let's do our cross products. So, can you, without a calculator, do you know what 12 times 9 is? 108, there we go. Okay, let's distribute 4 through all of this. We can do that. We can distribute 4 times 4x. What's 4 times 7? 4 times 7, 28. Okay, take it from there. Let's subtract 28 over. You got it. What's 108 minus 28? Divide by 16. Final answer is 5. Got it. Got it. So easy, this is one of those things that's easy, but I think a little tricky because you have to look at those similarity statements and be matching up the correct sides, especially when they label everything, my friends, okay? So just be conscientious of that. This is why